Good morning, children. Today we are going to see few more problems on dual nature of radiation and matter. Take your physics note and take the note, children. I'm going to solve the problem one by one. Take the notes and write the same in your physics note. Okay, when you're coming back to the school, I'll check all the things. Okay, we'll go to the problem. But children, exercise 11.8. Let us see the solution.
Threshold frequency for a certain metal is 3.3 into 10 power 14 Hz. If light frequency 8.2 into 10 power 14 Hz is incident on a metal, predict the cutoff voltage for the photoelectric emission given. H and E is given, children. Now let us see how can we solve the solution. Once again, I am reminding you what is a cutoff voltage. Cutoff voltage is nothing but threshold voltage. Okay, children? We know that K max equal to H nu minus W R phi naught. Just we are going to rearrange this equation, then we'll get E v naught equal to H nu minus, instead of phi naught we can write H nu naught. Okay, then what is the thing we are going to find out? We are going to find out V naught. Then what is the given things here? Nu naught is given, that is 3.3 into 10 power 14 hertz, comma nu equal to 8.2 into 10 power 14 hertz. Okay, this is the given. Then what is the thing we are going to find out? We are going to find out V naught. Then rearrange this equation. You'll get V naught equal to H nu minus nu naught divided by E. Substitute the values, you'll get what you'll get. V naught equal to 6.63 into 10 power minus 34 into 8.2 minus 3.3 into 10 power 14. If you are taking the powers out, you'll get like this. Then divided by what is the E value? 1.6 into 10 power minus 19. Then you are solving this equation, you get V naught equal to 2.03 volts. Okay, children, this is the final. Next we are going to see problem 2. So last year, that is 2008 board question. Two lines A and B in the plot given below show the variation of the Broglie wavelength lambda versus 1 by root V, where V is the accelerating potential difference for two particles carrying a same charge. Okay, carries the same charge. Which one of two represents a particle of a smaller mass? Okay, this is the graph. Okay, very simple. Two particles is there, same mass is there, but we are going to find out which has the smaller mass. Before that, we should know that characteristics of graphs. Okay, as we discussed in the earlier class, what is the slope? Slope is nothing but, okay, see, the slope is nothing but y divided by x. See this one, children. If x is very large, the slope will be small. Okay, if x is very small, the slope will be large, because both are inversely proportional. Now you see the graph. Okay, you see the graph here. See this one. Take slope of A metal. Take the slope of B. Slope of B will be smaller than slope of A. Okay. Oh, according to de Broglie wavelength, according to de Broglie wavelength, lambda equal to h divided by root of 2mb. Okay, it's the same charge. See, what is the slope? Slope is nothing from the graph. From the graph, slope is nothing but lambda divided by 1 by root V. And substitute the value. What is the lambda value? H divided by 2 M E V. That is root 2 M E divided by root V divided by 1. That V it will cancel. Then what will get, children? Slope equal to H divided by 2 M E. It's the same charge. Then what is the proportionality of slope and mass? Slope is a constant, H is a constant, 2 is a constant, M is 1 is a variable, E is the constant, then 1 divided by root slope is inversely proportional to mass. See the graph, which has a larger slope, A has a larger slope. Then we'll have the from the graph, slope of B is larger because X is very smaller. What is the slope? Again I am saying slope equal to Y by X. Okay, X is smaller, the slope of B will be larger. And see the thing, M is slope is larger, M will be smaller. Then right, slope of B will be greater than slope of A. Then very simple, mass of B will be less than mass of A. Then what is the solution we found out? Okay. Problem 3, children. The equivalent wavelength of a moving electron has the same value as that of photon of energy 6 into 10 power minus 17 joule. Calculate the momentum of the electron. Okay, we are going to find out the momentum of electron. Have you noticed, children? This sum, the energy value is given in terms of joules. Then no need to convert. Already they are given in joules. Then no need to convert it again into the joules unit. Okay, we can take the value directly from the sum. Okay, what is given? E energy is given. Energy, that is solution, right? Solution energy E equal to 6 into 10 power minus 17 joule. What is the thing we are going to find out? We are going to find out momentum. What is momentum? P equal to H divided by lambda. First we can find lambda with the help of energy. We know that what is the energy? E equal to H nu. What is nu? H C divided by lambda. Substitute the value, get the lambda value. Then lambda equal to H C divided by E. What is H? H is nothing but 6.625 into 10 power minus 34 into 3 into 10 power 8 divided by, what is E? 6 into 10 power minus 17. Then when you are solving this one, you will get lambda equal to 3.31 into 10 power minus 9 meter you will get. Otherwise, nanometer. Okay, it's nanometer. Then substitute the value. P, what is P? P equal to H divided by lambda. What is lambda? Just now we found H. What is 6.625 into 10 power minus 34 divided by lambda 3.31 into 10 power 9 meter. Okay, then when you are dividing, what will get? You will get the momentum value 2 into 10 power minus 25 kg meter s minus 1. Okay, with the unit if you are writing, you will not be given full mark. Okay. Problem 4. For what kinetic energy of neutron will be associated the de Broglie wavelength 1.4 10 power minus 10 meter. Okay, see the first subdivision. Then we are going to find out de Broglie wavelength. We know that what is solution given, kinetic energy is given K equal to 1.38 into 10 power minus 23 joule K. K is a constant, children. It will be given here. Question. Don't worry. K equal to 1.38 into 10 power minus 23 joule Kelvin minus 1. Now first subdivision we are going to find out lambda. Lambda equal to h divided by 2mk. Take square on both sides. What will get? We'll get lambda square equal to h square divided by 2mk. Rearrange k equal to h square divided by 2m lambda square. Okay, this is the thing. We're taking square on both sides. Now substitute the values. Okay, so if you're substituting the values, what will you get? K equal to 6.63 into 10 power minus 34 divided by 2 into 1.677 into 10 power minus 27 into 1.40 into 10 power minus 10 the whole square is given. Okay, lambda value is given. Then when you are now dividing the values, we will be getting 6 to 68 into 10 power minus 21 joule. Okay, 21 joule. Convert in terms of electron volt. Joule to electron, we should divide by 1.6 in 10 power minus 19 joule. That will get 6.68 into 10 power minus 21 divided by 1.6 into 10 power minus 19. Okay, then when we are dividing, we will be getting 4.174 into 10 power minus 2 electron volts. Okay, next subdivision. K is given, K equal to 3 by 2 KT. Temperature is given, T equal to 300 Kelvin. K value is already given. It is a constant 1.38 into 10 power minus 23 joule Kelvin minus 1. You know the formula. What is de Broglie wavelength formula? Lambda equal to h divided by 2mk. Substitute the value h divided by 2m 3 by 2 kt. 2 it will cancel. Then we will be getting h divided by root of 3mkt. Okay, this is the value. Substitute the values will be, when we are substitute the values, 6.63 into 10 power minus 10 divided, 34 divided by root of 3 into 1.677 into 10 power minus 27 into 1.38 into 10 power minus 23 into 300 meter. Okay, when you are solving, we will be getting lambda equal to 6.63 into 10 power. Powers, if you are solving, you will get 10 power minus 10 root of 20.8. Then we are getting 6.63 into 10 power minus 10 divided by 4.56 meter. Then we are dividing, we are getting 1.45 into 10 power minus 10 meter or 0.145 nanometer. Okay, children, this is the thing. Problem 3. 0.18. Okay, what is the problem? So that the wavelength of electromagnetic radiation is equal to the de Broglie wavelength of its quantum. We know that what is quantum? Quantum is nothing but photon. Okay, we need to show that the electromagnetic radiation is equal to my de Broglie wavelength, that is lambda. Okay, we know that what is lambda? Lambda is nothing but h by v. Okay, let's see the solution. As we know that for photon de Broglie wavelength is nothing but lambda equal to h by p. Okay, let us consider the lambda dash is the electromagnetic radiation wavelength. Okay, it has the frequency nu. Okay, we can write lambda nothing but c divided by v. Now what is our thing? We need to show that both the wavelength of this wavelength lambda and lambda both are equal. For that, what I am going to do, I am going to write the momentum in terms of energy. Okay, how can we write? Very simple. We know that momentum can be written as, you know that E is equal to h nu. What is nu? Nu is nothing but c divided by lambda. What is this lambda divided? What is this h divided by lambda? Children, we know that what is p? P is nothing but h divided by lambda. Then this can be written as E equal to this one h divided by lambda can be written as P into C. P is the momentum. Then what is P? P is nothing but E divided by C. Very simple. Then this one can wait, children. It can be written as P equal to E divided by C. This can be what is E is nothing but h nu divided by C. Very simple. Then substitute. Now what is nu? Nu, very simple. We know that lambda dash equal to c divided by nu. From there you find out what is nu. Nu is nothing but c divided by lambda. Substitute here, what will get? H divided by c. C divided by lambda dash. C it will cancel. Then we will get h divided by lambda dash, which is equal to p. Then rearrange this one. Rearrange this equation, children. What will get? Very simple. Lambda dash equal to h divided by p. Okay. If you are rearranging, what will get? Lambda dash equal to h divided by p. What is h divided by p? It's nothing but lambda. Then we prove that lambda dash equal to lambda. Very simple. Thus, the wavelength lambda dash of the electromagnetic radiation is the same as the de Broglie wavelength lambda. De Broglie wavelength lambda. We proved that both the lambda are same. The quantum. Okay, quantum or photon. Okay, children, very easy. Next problem, children. An electron and proton are accelerated through the same potential. Which one of the two has first one greater value of de Broglie wavelength, second one less momentum? Just what very easy question, children. Just we are going to write lesson. Then we are going to prove which one has a greater wavelength, which one has the less momentum. Okay. Solution, children. We know that de Broglie wavelength. What is de Broglie wavelength? Lambda equal to h divided by root of 2mqv. Okay, that is 2mev. Here let us consider generally we can write charge as q. That's why we wrote 2mev. Then for same v is same. Okay, then v is same means v is constant, 2 is constant, h is a constant, then lambda is a constant. Then we can write lambda is inversely proportional root of mq. Okay, we can write like that. Generally we know that mass of proton is greater than mass of electron. Then very simple, lambda of electron will be greater than proportionality, children. Very easy. Mass of the proton is larger means lambda will be smaller. mass of the electron is smaller, lambda will be larger. Then which will have the greater wavelength? Electron. That is, electron has a greater de Broglie wavelength. You must write like this, children. Without don't write solutions like mathematics problems. You should write the final conclusion. Okay, next let us see the second subdivision. Second subdivision, which one has the less momentum? Okay, we'll write the momentum equation, then we will discuss which one has a greater. We know that P equal to root of 2m EV. Okay, we'll write we know that charge of electron and proton, only the plus and minus sign it will change then. Okay, then let us take E as a constant. What is the charge of proton? Is 10 power 1.6 in 10 power minus 19 coulomb is the charge of proton. What is the charge of electron? Minus 1.6 into 10 power 19. Okay, minus 9, that is a charge. So that is charge of proton. Charge of proton is then 1.6 into 10 power minus 19. Electron is minus 1.6 into 10 power 19 coulomb. So both are really constant, only the minus sign is there. Let it be a constant that take proportionality. P is directly proportional to root m because V is a constant. Okay, clearly given. Then we know that mass of the proton is greater than mass of the electron. Then which momentum will be greater? Proton momentum will be greater than momentum of electron. But some they have asked which one has a lesser momentum. That means we should write electron has lesser momentum. Lesser momentum. Okay, children. Sometimes they'll ask which one has a greater momentum. You should write proton has a greater momentum. But you must keep in mind mass of the proton is always greater than mass of the electron. Okay, children. Next question, children, is a board question. The figure shows the variation of stopping potential V0 with the frequency nu of the incident radiation for two photosensitive metal P and Q. The figure is given. That is a graph between V0 versus nu. So straight line, as we know that threshold frequency value is given. For P metal is 0.1, for Q metal is 1.0. Okay, what are the questions? Let us see. First question. Explain which metal has a smaller threshold wavelength. Okay, first question. The second subdivision. Explain, giving reason, which metals emit photoelectrons having smaller kinetic energy for the same wavelength of incident radiation. Once again, I am reading the question, children. Explain, giving the reason, which metal emit photoelectrons having a smaller kinetic energy for the same wavelength of incident radiation. Okay, then final subdivision. If the distance between the light source and the metal P is double, how will the stopping potential change? Okay, let us go to the solution. I'll solve one by one. Okay, children. Okay, what is the first subdivision, children? Which one has the smaller wavelength? See the graph. Q has 1.0 threshold frequency. P has 0.1 threshold frequency. Okay, just we'll go for the solution. We know that what is the threshold wavelength equation? We know that threshold wavelength lambda naught equal to C divided by nu naught. What is the proportionality? Lambda is inversely proportional to nu naught, which has we know that for Q metal, for Q, nu naught equal to 1.0. into 10 power minus 15 second minus 1. For P nu naught equal to 0.1 into 10 power 15 second minus 1. Okay, this is the data which is given in our problem. Okay, see the graph, then you will understand what I am saying. Okay, children, see what is the proportionality. If nu is larger, the lambda will be smaller. What is our question? Which metal has a smaller threshold wavelength? Very simple. Which has a greater threshold frequency? Metal Q. Then very simple, lambda naught of, that is the threshold wavelength of Q, will be smaller than threshold wavelength of P, because what is the proportionality? P is smaller, then lambda will be larger. Okay, children, very easy. Write the stage conclusion. Thus, metal Q has smaller threshold wavelength. Threshold wavelength. Okay. Second subdivision is explain the giving reason which metal emits a photoelectron having the smaller kinetic energy for the same wavelength of incident radiation. Okay, that means we should find out which electron will having a smaller kinetic energy. That is, which metal has the smaller kinetic energy electrons. Okay, very easy. See the graph. What is the new value for P is 0.1. What is the new value for Q is 1. Okay, very simple relation, children. Second one, we are going to write the solution, right? As we know that energy of photon is given by E equal to h nu. What is the proportionality? E is proportional to nu naught. Okay, energy is directly proportional to nu. Which one has a smaller frequency? See the graph. Which one has a smaller frequency, children? Very easy. P has a smaller frequency. Then which will have the smaller kinetic energy? Metal P will have the smaller kinetic energy. Hence, because what is P? For P is 0.1 nu. Okay, for P 0.1 new value. Okay, for P of nu. Okay, for Q, what is the new value? Is 1.0, which will have like a smaller kinetic energy. Very easy. See that. Which what is the proportionality between the nu and E? Directly proportional. B has a smaller nu. Then hence metal P has smaller kinetic energy. Kinetic energy. Okay. Metal P has a smaller kinetic energy. Subdivision, children. The distance between the light source and metal P is double. How will the stopping potential change? Okay, very simple. Right. Third solution. If the distance between the light source and metal P is doubled, stopping potential remains unaffected. I'll tell you why. Remains unaffected because the value of stopping potential for a given metal surface does not depend on the intensity. Okay, intensity of the incident radiation. It depends on the frequency. Frequency. It depends on the frequency of incident radiation. Okay, children. Very simple. If you are keeping the far distance from the metal, that means what will happen? If you are keeping the light nearby your eye, the intensity will be more. If you are keeping the light far away from your eye, what will happen? The light will be dim. We know that whether light is dim or intensity, stopping potential does not depend on intensity. Okay, children. If you are keeping the distance of light source from the p metal or q metal, if you are changing, there will not be any effect on stopping potential. Okay.
The take down, note down, children. NCRT exercise 11.4, 5, 6, 7, 11 to 11.6 and 11.9 is a homework. Okay, these are the homework. Write it in your physics note, take a snap and send it to me through mail. Okay, many of you not sending your homework. Please send, unless and until and unless if you are not sending the homework, we will not give the mark. Okay, children, keep it in your mind. When you're coming back to your school, you must submit your homework note. Okay, take care, children. Now you go on to do your homework. Stay safe and learn physics. Okay, bye, children. Take care.